It's a crisp January morning at Kennedy Space Center in Florida. The sky is clear and the weather conditions are perfect for launch. 7 astronauts make their way across the gantry, their white suits gleaming against the towering orange external tank of Space Shuttle Columbia. They've trained for years for this moment, preparing for what would be a groundbreaking 16-day research mission in Earth's orbit. The crew exchanges final words with ground control as they settle into their seats, unaware that a seemingly minor event during their ascent would seal their fate 2 weeks later. This is the story of Columbia, the Kennedy Space Center, Florida. Space Shuttle Columbia sits on Launch Pad 39A, her cargo bay loaded with scientific experiments and research equipment. She's the oldest shuttle in NASA's fleet, having first flown in April 1981 as the very first space shuttle to reach orbit. Now, 22 years later, she's preparing for her 28th mission. The veteran orbiter measures 122 feet in length and weighs over 2 million pounds when fully fueled. Her crew of 7 represents an international partnership in space exploration, including payload specialist Ilan Ramon from the Israeli Space Agency. Mission STS-107 has been years in the making. Originally scheduled to launch in January 2001, the mission faced delay after delay for nearly 2 years. Technical issues, scheduling conflicts, and budget constraints pushed the launch date back repeatedly. But finally, on January 16, 2003, Columbia is ready to fly. The 7-member crew includes Commander Rick Husband, pilot William McCool, mission specialists David Brown, Kalpana Chawla, and Laurel Clark, payload commander Michael Anderson, and payload specialist Ilan Ramon. Unlike many shuttle missions focused on International Space Station construction, STS-107 is dedicated entirely to pure around-the-clock in 2 shifts, conducting over scientific research. The crew will work and combustion research fill their ambitious multiple disciplines. Life sciences, material sciences, fluid physics, 80 experiments across orbiting Earth every 90 minutes. The boundaries of human knowledge while schedule. For 16 days, they'll push. At 10:39 a.m. Eastern Time, Columbia's 3 main lifts off from Launch Pad 39 engines roar to life, followed by the twin solid rocket boosters. The massive Vehicle A accelerating rapidly through the morning sky. Mission Control in Houston tracks every second of the ascent as Columbia climbs toward orbit. The launch appears flawless, with all systems performing nominally as the shuttle gains altitude and speed. But 81 seconds after liftoff, high-speed cameras capture something troubling. A large piece of orange insulating foam breaks away from the external tank's left bipod ramp area. The foam, roughly the size of a briefcase, tumbles through the air before striking Columbia's left wing leading edge with tremendous force. The impact occurs at a combined closing speed of over 500 miles per hour. But from Mission Control's perspective, the event seems insignificant. Foam shedding had occurred on previous shuttle missions without causing serious damage. NASA engineers and managers view it as a maintenance issue rather than a flight safety concern. The foam strike is noted in post-launch reports, but no immediate action is taken. After all, Columbia has already reached orbit successfully, and the crew is beginning their scientific work as planned. Over the following days, some engineers expressed concern about the potential damage to the wing's thermal protection system. They request high-resolution imagery from military satellites or ground-based telescopes to assess the impact area. These requests move through NASA's bureaucratic channels, but face resistance from management, who believe such imagery is unnecessary. The prevailing attitude suggests that even if significant damage occurred, nothing can be done to repair it in space. Meanwhile, Columbia's crew remains blissfully unaware of any concerns on the ground. They're fully engaged in their research mission, working tirelessly to complete experiment after experiment. The astronauts exceed all expectations for scientific productivity, gathering invaluable data across multiple fields of study. Mission specialist Kalpana Chawla, a fan of the rock band Deep Purple, even brings 2 of their albums with her on the mission. The crew's dedication and enthusiasm for their work shines through in every communication with mission control. As the mission progresses, the foam strike fades from immediate attention. Columbia continues orbiting Earth, her crew conducting groundbreaking research, while the damaged thermal protection tiles on her left wing remain hidden from view. The 16th day of Columbia's mission arrives with the same routine precision that has marked the previous 2 weeks. The crew completes their final experiments and begins the methodical process of securing equipment for the journey home. Commander Rick Husband and pilot William McCool review the deorbit procedures, while their crewmates stow scientific samples and personal items throughout the mid-deck. The atmosphere aboard Columbia is one of satisfaction and accomplishment. They've exceeded every scientific goal set for the mission. At Mission Control in Houston, flight controllers monitor weather conditions at Kennedy Space Center. The forecast looks favorable for landing, with clear skies and light winds expected. The flight dynamics team calculates the precise deorbit burn required to bring Columbia home safely. Everything appears nominal as preparations continue for the crew's return to Earth. On the morning of February 1st, Columbia's crew awakens to begin their final day in space. They conduct the traditional crew photo session and pack the last of their belongings. The shuttle has been their home for over 2 weeks, and there's a bittersweet quality to their departure preparations. Mission Control briefs them on the timeline for deorbit and entry, emphasizing the nominal nature of all systems. At 8:15 a.m. Eastern Time, Columbia fires her orbital maneuvering system engines for 2 minutes and 38 seconds. The deorbit burn slows the shuttle by just over 200 miles per hour, but this seemingly small change is sufficient to drop Columbia out of orbit and begin her descent toward Earth's atmosphere. The crew secures themselves in their seats as the shuttle begins its transformation from spacecraft to glider. Entry interface occurs at 400,000 feet above the Pacific Ocean. Columbia encounters the first wisps of atmosphere, and her reaction control system thrusters begin working to maintain proper attitude. The shuttle's heat shield starts absorbing the tremendous energy of re-entry as atmospheric friction converts orbital velocity into heat. On the flight deck, the crew watches familiar procedures unfold as their spacecraft becomes surrounded by the characteristic orange glow of superheated plasma. Mission Control continues tracking Columbia as she streaks across the Pacific toward the California coast. The entry appears completely normal, with all telemetry indicating proper performance. The shuttle's computers automatically adjust her flight path to target the runway at Kennedy Space Center, still over an hour away. Flight controllers see nothing unusual in the data streaming back from the orbiter. At 9 a.m. Eastern Time, Columbia crosses the California coastline at Mach 23. Her heat shield glowing white-hot as she slices through the thickening atmosphere. The crew feels the familiar buffeting of re-entry as aerodynamic forces begin to take hold of their spacecraft. But deep within the left wing's leading edge, superheated gases are finding their way through the breach created by that piece of foam 16 days earlier. The damaged thermal protection system can no longer withstand the extreme temperatures of atmospheric re-entry. Mission Control receives the first sign of trouble at 8:53 a.m. when sensors in Columbia's left wing begin showing unusual readings. Temperature measurements spike beyond normal parameters, and tire pressure data becomes erratic. Flight controllers exchange concerned glances as more warning indicators appear on their screens. Commander Husband acknowledges the first calls from Houston, but his transmission cuts off mid-sentence. At 9 a.m., traveling at 18 times the speed of sound, Columbia begins to break apart over East Texas. The extreme heat has melted critical structural elements within the left wing, causing catastrophic failure of the orbiter's airframe. The crew compartment separates from the fuselage, tumbling through the morning sky as debris spreads across hundreds of square miles below. For the 7 astronauts aboard, consciousness is lost within seconds as cabin pressure drops to 0. On the ground, thousands of witnesses across Texas and Louisiana see Columbia's final moments as streaks of light racing across the dawn sky. What should have been a routine homecoming becomes a scene of unimaginable tragedy. Search and rescue teams deploy immediately, but they're looking for debris rather than survivors. The investigation that follows reveals the full extent of NASA's organizational failures. The foam strike that seemed so insignificant during launch had punched a hole through Columbia's wing leading edge. Engineers who raised concerns were dismissed, and requests for imagery to assess the damage were denied. Most heartbreaking of all, the investigation concludes that Columbia could have remained in orbit until a rescue mission arrived, or the crew might have been able to repair the damage themselves. The Columbia accident stands as a stark reminder that in human spaceflight, there are no minor incidents, only major accidents waiting to happen. 7 dedicated explorers paid the ultimate price for institutional complacency and the normalization of risk. Their sacrifice led to fundamental changes in NASA's safety culture. But for the families of Rick Husband, William McCool, Michael Anderson, David Brown, Kalpana Chawla, Laurel Clark, and Ilan Ramon, those changes came too late. Today, Columbia's legacy lives on through the scientific discoveries made during her final mission and the lessons learned from her tragic end. The crew's dedication to advancing human knowledge serves as an enduring testament to the courage required to push the boundaries of exploration, even when the risks are beyond our full comprehension.